Hello, my name is Alex Liu, and I'm a member of Dr. Chizong's lab at the IU School of Medicine and a current high school student at Park Tudor. Today, I would like to go over an overview and introduction of scFlux, a web server used to estimate cell sample-wise metabolic fluxome by using scRNA sequence or general transcriptomics data. So to start, this server provides end-to-end analysis and has several different tabs. We will first start with the Run scFEA tab. This tab is where you input your data and where the system analyzes your data. So to start, let's do what it says in step 1, select species. Here we will select mus musculus, the mouse. Next, we will select network. If you want a more generalized network containing the majority of metabolic pathways, select M171. Otherwise, if you want a more specific pathway, you can select one of the other 8 pathways. This time we'll choose one of the pathways. Next, let's choose an input data file. So here, I will just choose an example CSV file. While the file is uploading, I will go over some of the basics. The input of scFEA is a single cell RNA sequence or general transcriptomics data in which each row is one gene and each column is one sample. Next, scFEA web server only accepts CSV space txt or tab txt delimited input files. So if your file is not in one of the following formats, please reformat it and resubmit. Finally, it may take a few minutes to upload a data size larger than 100 megabytes. So that may take a little more time than the upload here. Let's go to step 3 next. Step 3 is the data optimization section. This includes imputation and normalization. If your data has a lot of zeros, it is recommended that you perform imputation. For normalization, generally log normalization is used for most data. However, more information on this can be found in the tutorials tab. I will take a quick look here. Server tutorial is where you will find most of the additional information on the different steps, and we'll go back to this at the end of this presentation. On step 4, now that we have selected settings for all of the previous steps, now we will submit our task. As you can see, a task ID is assigned to every task that is submitted. This task ID can be used to access the data later after the calculations and analysis is complete. While the analysis is running, let me go over some of the other tabs and what they contain. The Downloads tab contains example input files, a carefully curated selection of module files, and expected results derived from commonly utilized datasets and single-cell RNA sequence datasets. So if you do not have your own data or you just want to try it out, these will be good input files to run and compare to the commonly utilized dataset results. Next, let's move to the results tab. As this trial is still running, let's take a look at one of the previous analyses. The analysis shows you a table of the data that was inputted and shows you some aspects of the data. The first section is input data, which shows you an intermediate input of scFlux extracted from your input. The output files show 1, the predicted flux, and 2, the predicted metabolic variance of the major results. And 3, module information shows the annotations associated with the data in the output files. Finally, if you want to do a downstream analysis of your data, take a look at package tutorial 1. This includes a video introduction that gives more detail on how to analyze your data downstream after this initial analysis has been completed. Thank you for watching and good luck on using SC Flux. I hope you have an enjoyable experience and see you later.